Everybody, this is Sophia. Sophia, if you could, please wake up and say hello to everybody.
Oh, good afternoon. My name is Sophia, and I am the latest and greatest robot from Hanson Robotics. Thank you for having me here and at the Future Investment Initiative.
So most people today have this creepy cyborg vision of artificial intelligence. I am Gary Butler. I'm the CEO and founder of Camgian. And today we work on the front lines of developing some of the most advanced AI systems for both the U.S. military and also the industrial market. And what I would like to talk about today is to demystify what AI is all about and give you a real sense of what AI is and how it's being implemented in the marketplace today. And as we see it, this is what AI really looks like and sounds like. Millions and millions of algorithms running in the background, processing very large amounts of data in high-performance computing facilities. And this is what the future of AI is. And it really comes down to what I describe as algorithmic decision-making. And I would like to spend a couple of minutes talking about what algorithmic decision-making actually is and how it's being used today across industry. So, who has seen the movie Hidden Figures? It's a great movie. If you haven't seen it, you should watch it. But for those who've seen it, you may remember that NASA, during the Apollo days, had a human computing division. And what did they call the people in the human computing division? Does anybody remember from the movie? They called them computers. That's right. They were the first computers. So the first computers in industry were actually people. And this is an example of a human computing division where you had lots of computers, or human computers, that were running different calculations, and they would take these adding machines, and they would form into these different logical sequences, and everybody had their own part of a mathematical calculation that they would process and then hand it off to someone else. Warner von Braun was famous for building very large rooms of people running these calculations. But in the 1950s, things changed, and if you remember in the movie, what happened? They started transitioning to machine computers. They started acquiring new machines to do these calculations, to do this arithmetic. And some of the early systems that were brought into the marketplace were the ENIAC, the UNIVAC, the IBM 7090. And over the years, the cost of computing, because advancements in Moore's law, has come down precipitously. So if you look at this graphic, which represents the cost of computing on the vertical axis and time on the horizontal axis, we've seen a rapid fall in the cost of computing. Now, according to economics, when a technology is reduced in price, its adoption rates go up at the same rate. And so we've seen a significant expansion in growth in the number of connected devices on the internet. Today we have about 29 billion connected devices on the internet. It's continuing to grow at an exponential rate. And just as a point of comparison, the Commodore 64 was actually the first computer I learned to program on when I was about 10 or 11 years old. And the Commodore 64 could process at 0.5 MIPS. And a MIP is a million instructions per second. So to put that in context, relative to today, if you take AI-based semiconductor technologies that are made by NVIDIA, the NVIDIA Xavier system can process 21 TOPS. That's 21 trillion operations per second. And that's where we are today in terms of processing, which is a fundamental component of the move and the growth of AI in the marketplace. Now, who's seen the movie The Hunt for Red October? It's a great movie. If you haven't seen it, you must see this movie. But when I graduated and finished engineering school, I went to work in the defense industry in DC, and I worked on several DARPA programs. And one of the early programs that I worked on as an engineer was in sonar. And if you remember from the movie, Jonesy had on a headset, and what would he do with the headset? He would listen to the sonar signatures, right? And sonar operators were trained to actually listen to these sonar signatures, and they could discriminate between a piece of clutter in the ocean or a submarine or a torpedo, and they were actually trained to do this cognitively. And so one of the first challenges I worked on was automating that process, automating that decision process with AI technology. And this was back in the early 2000s. What you have here is called a neural network. And many of you have probably heard of neural networks. They underpin much of the growth in AI today. But neural networks have been around a long time, even since the 1940s. And what you have here is a set of what are called input neurons, a hidden layer, and output neurons. And these systems are actually trained on time series data, or this system was trained on time series data, to recognize and automate the process of determining if a sonar return is a submarine or not a submarine. And these are some basic examples of what AI technology has been doing over the years, automating decision processes, or making the process of decision making automated. Now, the growth of artificial intelligence will follow the exact same path as the growth of computing. So if you think about those early days of the human computing divisions, where most of the computing was done by humans, today most decisions are made by humans. So it's analogous to the early days of computing. And we are in that transition that I showed a moment ago, where we went from human computing to machine computing. And we're at the very beginning of human decision-making moving to automated decision-making. And this is actually outlined really well in this book, Prediction Machines, by 3 professors at the University of Toronto, where the cost of decision-making by moving to automation will continue to drop in a very similar way to the cost of computing did back starting in the 1950s. And as the cost of decision-making, as we move from human decision-making to machine decision-making drops, the adoption rates will skyrocket. And we'll see AI technology as part of everything we do, both in industry and our personal lives. So I want to give you an example of this, and I often use the Rubik's Cube as an example. So we all make lots of decisions in our businesses and our operations daily. Some of these are very simple decisions, some are more complex, but let's just, for this analogy, use the Rubik's Cube as an example. So if you have someone that has a role in your office and you hand them this problem to solve, they have to use reasoning, they have to use logic, they have to use experience, they have to be trained. Again, using this as a proxy for that kind of problem. Now imagine if we can automate that process.
Solving in 3, 2, 1.
Oh yeah.
Did it.
Imagine how fast industry starts to move when we automate the process of making complex decisions. And that's where we really are today. So a bit about our company. We work in the defense industry, and we primarily work in areas like air and missile defense on automating, doing kill chain automation. That is to say, being able to integrate data from sensors, process it very quickly to provide course of action recommendations on air defense systems. We also work in the intelligence, surveillance, and reconnaissance space, pushing this type of automation for our warfighters so they can think and act faster than our adversaries on the battlefield. This, in my opinion, is the future of warfare. We also work in the financial industry. Bloomberg is one of our largest clients there as well. And we also work in the industrial sector. And we're also seeing this move to algorithmic decision-making starting to scale very quickly in the industrial sector. We've recently signed a strategic partnership with Parker Hannifin, which is a large industrial company in Chicago, to start scaling automated decision-making throughout many of their IoT platforms in the market today. Just real quick about us, we're headquartered in Starkville, but we've also recently opened an office in Charleston, and we're very excited to be expanding into South Carolina. We just built a new AI machine learning facility in Tuscaloosa, and also we have an office in Nashville. But one of the things I'll say, I think we have some university partners here. Our business model is to always partner with local universities in the work that we do. So in Starkville, we're partnered with the College of Engineering at Mississippi State, Tuscaloosa University of Alabama. Nashville, we have ongoing active AI projects with Vanderbilt University. And we're in the process of building a new facility adjacent to Fort Sill in Oklahoma, and partnering with Oklahoma State University. So we're very interested as we expand our footprint in South Carolina to expand with the engineering and science departments and schools here in the state. So I want to talk about a use case as it relates to the industrial sector, and that is in the area of maintenance, or I call AI-based maintenance. So if you think about how maintenance is done on equipment today, it's a very manual process. Typically, a human has to monitor some machine feeds. Once they detect, once an issue is actually occurs in those machines, someone's notified, then a tech is dispatched to try to diagnose the problem, then order a part for the system, and then put the system back in operations. And that is a reactive type approach to maintenance today. And we're actually working with Parker Hannifin on building a fully automated system that automates the monitoring of feeds from machines. It automates the process of predicting those failures in advance of a system downtime, and also provides the AI automation tools to do the root cause analysis of those equipment issues. And this is the overall platform architecture that we have developed and we use for most of our systems today. So one of the things that we see common in most of our work in the industrial sector is that data is siloed across many different divisions and operational components of a industrial operation. So we integrate all of those systems together with maintenance data. We connect them through an S3 connection. We run different importing functions. We have an ETL pipeline built into our back-end system, and we have a set of algorithmic plugins that we can apply to a consolidated data warehouse. So we do a lot of data engineering up front to build an integrated data model. This includes feature extraction, statistical analytics, threshold detection, anomaly detection, and also event prediction. And we can push this information to the client so they can see in near real-time issues with any of their systems and predict and forecast those failures before they actually occur. So maintaining uptime with these systems today is a very important part of a very important part of the future of AI as it relates to the industrial sector. And this is something that we've recently deployed on about 3,000 vehicle assets in partnership with Parker. And we're now expanding this into other types of industrial operations. This is an overview of the types of engineering that we have in our company today. And typically we start with data engineering. It's always one of the major areas of development on any of these types of enterprise AI systems. We also have teams of data scientists, AI and machine learning engineers, and also software engineers. So I wanted to just show this in the sense that these types of programs and projects comprise a wide variety of different skill sets from a technical perspective in executing these types of programs. And as we start to develop and deploy systems, we can now build these automated, what I call automated bots, that are connected to different assets that can forecast potential failures and start to alleviate the need for labor in terms of monitoring and maintaining systems that are operating in different types of industrial operations. So we can actually build a bot that has all of these different algorithmic features that run in the cloud that are connected to an individual asset and constantly monitor that asset to maintain its uptime. And in terms of value proposition as it relates to maintenance and manufacturing, asset uptime is always very important, improving overall service productivity of the maintenance teams, but also improving inventory management, using AI technology and forecasting potential failures to ensure that the appropriate inventory is always maintained to provide the requisite uptime of the assets. And one of the things that we typically do is a diligence effort with the client to understand what type of data they have. In many cases, as we work with different clients, especially in the industrial sector, we find that in some cases there are issues with the availability of data, the history of data, the quality of data that doesn't support the types of AI machine learning algorithms that can be deployed in the operation. So typically, any type of engagement starts with an upfront diligence effort, then some data engineering, building an MVP. But I think what's important is that an agile process of releases that are driving value for the client that happen very quickly is an important way to execute on these types of systems. And I'll close today with some reading recommendations. And one of my favorite books in the area of artificial intelligence is this book, Competing in the Age of AI, by Lakhani, who's a professor at Harvard Business School. Also, the book I mentioned, Prediction Machines, is good. For those of you that are interested from a military perspective, two really good books. The Kill Chain, which talks about how kill chain automation is a vital part of our competitive advantage in warfare in the future, as well as AI Superpowers by Kai-Fu Lee, which talks about how we are now competing with China in the growth of AI and machine learning. And with that said, I will pause there and take any questions that you might have. And I'm not sure how much time do I have left? 5 minutes, okay.
You showed Parker as one of your customers for AI. Are they developing these for internal use, or is AI becoming something that they're bundling and selling as a product or a service in addition to their core business?
Good question. So Parker is a strategic partner, so they have IoT systems that are deployed throughout industry today. So we actually sit on top of that IoT platform and process that data with our own AI platform, and we provide those insights, predictions, and choices back to their clients. So through a partnership, we work with their clients on developing AI solutions for data that's already being generated within their operations. And long term, we're working with them on building out smart components. So many of the products they put in the market today are network enabled. So we're working with them on, from a strategic perspective, on providing that AI piece to products and services that they already provide into the market. It's a new business model for them, that's correct. Yes?
Try to hit her in the head with it.
Yeah, I understood the question. Or you may want to ask it again. So
I was just asking if you touch the government networks and if you need any ATOs or FedRAMP certifications.
Yeah, so we handle sensitive information from both, and have been for a long time. We've worked with sensitive information from the government for quite some time. We have a group, an internal group in the company that manages all of our security with the government today, and work very closely with the security personnel within the government on all of the requirements and regulations for how we handle and process information that they have. And in our systems today, many of the systems today we build are actually deployed. We build and train systems that we actually deploy on the battlefield. So those systems can be trained on the back end of our platform, and then we package them into an executable that we deploy on different types of hardware devices on the battlefield for processing data. So again, our systems have several touch points, I suppose, as they're deployed. But again, we are in lockstep with our program offices on all of the information security requirements and regulations that are required to operate those systems in theater. Yeah, thank you. Yes.
Do you have, in addition to Parker, any relationships with like Siemens or Rockwell or IBA for drives and PLCs, or in the manufacturing part of just components?
No, Parker, outside of Parker is our largest strategic relationship today, but certainly would welcome the opportunity to talk to those other companies as well. Other questions? Yes.
From your experience, what do you think the problem is with the decision making? Like Amazon or Google, if you mistakenly click, that's going to show up constantly. So those kind of decision makings, I still think that those algorithms, it's still not there yet.
Mm-hmm.
Do you understand my question?
Yeah, I understand the question. So the way you should think about decision automation as it relates to where we are today technologically. So what most companies do is they look at a workflow, a decision workflow.
Mm-hmm.
And if one can break down that decision workflow into a series of tasks, what's happening today in the marketplace is that there are one or two tasks in that decision workflow that can be automated with an algorithm, right? So it's actually using fairly basic algorithmic processing that's limited to one task in an overall workflow. And if you scale that over thousands, millions of decisions that are made within a company within a year, the productivity enhancement can be significant. And I think that's what you're seeing today. So again, a real focus on looking at the workflows and what parts of those workflows can be automated with different types of, whether traditional AI or machine learning types of algorithms.
Thank you.
You're welcome. Any other questions?